For those parents who realize that $600 isn't too much to spend to expand their child's world, Radio Shack has the perfect gift. The TRS-80 computer.
Yeah, if you're a massive dork. No, seriously, in today's money, that's around $3,000. The TRS-80 computer was released in 1977, and you'd be a lucky kid if your parents bought you one. A few years later, in the early 80s, Radio Shack also produced a synthesizer, which if your parents bought you one, might have scored you some more kudos points. Probably not. But anyway, at around $500 in today's money, that's around $1,600, which at the time was actually reasonable for a real synth. Okay, so I bought this off the internet, and it's probably got to be the cheapest one of the specific brand, although it's not technically that famous brand. In truth, I don't know what's inside this box, really. I mean, I have an idea, and I hope it is what I bought, but I don't really know. Let's rip into the box and see what's inside. One thing I do know about this synth is it's very broken. It's a Concertmate MG1. Did anybody guess that? The Realistic MG1 Concertmate is a monosynth with some unique tricks up its sleeve. It was sort of a joint venture between Moog Music and Radio Shack, released under the Realistic brand. So just to explain that a little bit, Radio Shack is an American retailer or electronics components and other sort of electronic stuff kind of people, which was later bought by Tandy Corp, who went on to make personal computers. Realistic was a brand name produced by Radio Shack for a range of its audio and video products, which were aimed at the home market. The MG1 was just that, a relatively affordable synth produced in high quantity and sold in Radio Shack shops. However, the only thing that really differentiates it from a professional instrument is the RCA jacks on the back for connecting it to domestic hi-fi equipment. There is also an input which just passes the audio direct to the output so you can play along to like a record or a tape or something. Although the MG1 was manufactured by Moog Music, it was actually designed by Paul Schreiber, who at the time was employed by Tandy Systems Development. However, David Luke of Moog Music was also involved. I'll get to the complete features later, but the more unusual addition is...
Say, I don't know, having a third nipple? You have a third nipple?
It's the Polyphonic mode, which is a simple top octave divide down organ circuit. My guess is that this feature may have been stipulated by the marketing and accounting people. You know, if you want to sell it to the home market, guys, it's got to play chords. Who ever heard of a piano that plays one note at a time? And we've also got to get Elton John on the adverts.
Rocket Man!
You know, something like that. Anyway, later Moog produced its own version, the Rogue, and a keytar version of the Rogue, the Moog Liberty. The Rogue was pretty similar looking, it came in exactly the same case, but it's an update of Paul's design, Paul's circuit. It adds a pitch and a mod wheel and removes the polyphonic section, and a few other features. So, in many ways, the MG1 actually does a lot more and was also a lot more affordable. As well as its price point, the MG1's distribution through Radio Shack's many stores, not just specialist music shops, meant that it sold in quite a high number, and therefore it's quite common, at least more common than a Rogue. Today many see it as an affordable way to get Moog bass tones. Of course we've also got like the Behringer Model D, but yeah. Does it have that vintage mojo? You can still pick one up for around £600 at the moment. Whatever that is in dollars or euros, roughly the same. Who knows? What are you doing? You eating the packaging? Don't eat the packaging. Naughty dog. Anyway, all I know about this one is it's very dead, doesn't power on. There could be a whole lot of shit wrong with this. If you're interested in seeing the resurrection of the Concertmate MG1 Realistic Synthesizer by Moog Music, stay tuned. There's literally no screws holding this together, so we can reveal the inside. Lots of stuff not connected, loads and loads of crusty corrosion. Over here we've got the mains transformer, which appears to have a hole in it. Does that even work? Let's see if we can zoom in on some of these integrated circuits. Yeah, you can see a lot of crap around those. Another thing, this circuit board is just loose. Loosey-goosey. I think fortunately a lot of these ICs are actually just standard parts and should be very easy to replace. I don't know what the other side of this circuit board looks like, so kind of flip it over and take a look. Okay. Don't think that looks too bad. Should be able to kind of clean that up. First thing I suppose would be check this fuse here. I mean, this clearly runs on probably 110 volts. I don't have a step down transformer here, so I'm not going to plug anything in tonight. We shall get to that later in the week. The fuse. Is this the correct fuse? This looks like it's highly overrated. What is this? What is it? 250 volt, 3.3, 4 amp, I think that says. This is probably not the correct fuse. That capacitor looks suspect. It's all sort of deformed and pretty ugly looking. U2, the edge is missing. Looks like something may have been soldered in here. Yeah, somebody's definitely been through this. Some of these sliders are pretty buggered. They don't actually really move very well. Maybe they clean up. Not really sure. But yeah, the whole thing needs to be taken apart really. Given a very good clean. And then get the multimeter out and start probing stuff again. So yeah, that doesn't look too pretty, does it? There's actually a trace running along the bottom here. Loads of corrosion and crap on that. Test some continuity across that. One end of the probe on there. And then let's see, oh, it appears to be going to one of the regulators. There we go, continuity, that's good. How about some of these iffy looking traces down here? Right, all I'm doing here is just checking to see if the corroded traces on the PCB are still intact and making a good electrical connection. So I've just got the meter set to continuity mode here and, you know, see if I'm getting a point-to-point connection. It may be okay. So yeah, on this board I believe obviously we've got power supply section here, bridge rectifier, smoothing capacitors, voltage regulators, and then all these ICs are connected to a sort of a divide down style organ. So as well as a monosynth, this has a basic kind of polyphonic sound. Curious to see what that sounds like. You can actually zoom in on that. Not sure how much this is actual corrosion or if it's just gunge. It does feel very gungy. You can actually probe some of these diodes, see what's going on. I think the legs are just covered in corrosion really. Actually, it might be easier to probe these from the other side. Oh my god! Come on. Diodes, diodes, diodes. Okay, what are you telling us? There we go. Kind of a 0.5 drop across that one. Same there, same there, same there. These all the same way round. That's good. Open lead. Open lead, open lead. So yeah, those diodes are all good. So that's a voltage regulator there, and that's a voltage regulator there. All seems all right. What about this one? So all I'm doing is just checking to see if there's any kind of dead short across these pins, or if we get a total sort of open lead, that would indicate damage to the voltage regulators. So yeah, my kind of concern here is that it's fitted with 110 volt transformer power supply, so it's obviously an American version. And yeah, you know, if somebody plugged it into UK voltage, which is 240 volts, and it's kind of fried something, but it doesn't look like that's the case. Normally what happens though is the fuse blows, or the primary side of the transformer blows. So that's all good. Let's put this to one side for now and take apart the other bit. Screws out. Yeah, not exactly exciting really, is it? Okay. Let's get a sneak peek. Yeah, it's equally as gross. Disgusting foam stuff that's disintegrated and made a mess of everything. Oh, come on. This is not the best way to do this. but I don't think this is ever going to be a particularly pretty looking synth again. Ugh. Come on, get out of there. Get out. Currently don't have a soldering iron set up or on or anything like that. Snippity snip. Done. You can see what's going on here. We've just got, there must have been like a foam sheet, and that's obviously disintegrated, as everything from the 70s and 80s that has foam in it suffers from that. Oh god, that's disgusting. Yeah, so you can see on top of these pots here, gunky disgustingness. And I dare say all of this crap has got inside the switches and the slide. Oh, this one slider doesn't even want to move properly. All this stuff has gone inside of this, I'm sure, and this whole thing moves. That ain't good. Why's that? Yeah, basically this all needs a really thorough clean. It's disgusting. It's gross. Yeah. Let's try cleaning it with some baking soda.
Never mind who you thought I was. I'm Rick James, bitch.
Right, yeah, you can certainly see what's going on now, like particularly around this area here. Couldn't really make out the individual tracks, it all just looked like one lump. But yeah, we can sort of see everything's kind of intact really, so that's a good start. Right, I've just rinsed that off under the tap, and I reckon that's looking a lot better. Let's have a go on this side, which is really gross. Wrinkle it over. Right, just leave that to fizz for a little bit. So yeah, there's still a load of gunge around some of the legs of these chips. I'm not sure how much that really matters. What's important is it looks like all these ICs have their pins intact. Before I couldn't really tell if they'd completely corroded through. Let's speed up the drying process. So I think this green stuff is actually just, yeah, probably like the protective varnish sort of coming off of the circuit board. Anyway, the electrical spray on there should drive out the rest of the moisture and sort of leave a kind of lubricant over it to sort of protect it going in. So what is the plan here? Well, basically there's all this kind of dried out gunky foam stuck on the top of these sliders, and the whole circuit board's disgusting really. So yeah, the plan is to scrape as much of that off, and then I'll probably go with the baking soda, contact cleaner type stuff. As you can see, I've already done this one. The other thing with a lot of these sliders is they're really kind of stiff, they feel horrible. So I'm just going to squirt a bit of contact cleaner in there and see if it loosens up. If anything, that's kind of made it worse. It's kind of improving. Definitely nasty though. Let's get some scraping. Lovely. Already an improvement. Ugh. Yeah, I mean, there's a strong possibility I might actually need to replace a lot of these. But we'll get it all clean and go from there. So you can kind of think of that as the before and the after. So I've got the vacuum cleaner out. Dog's probably going to go crazy when I turn it on. Dog hates the vacuum cleaner. Alright, looking at the transformer, this is the primary side, incoming mains voltage side. And yeah, it's got these 4 connections on it. So I wonder if it can be configured for 240 volts. I think first, put the meter on it, see if I'm getting any dead shorts or open circuits. 36 ohms across those two. What about these? So there's 37. 2 separate windings. I mean, they are kind of joined in series by the looks of it. Well, it's obviously going to do that, isn't it? Ugh. Try and disconnect this. There we go. 154 ohms across that. Any case, that suggests that that transformer is working and intact. Some of the sketchy wiring, these wires without any insulation on it, they need to go. I guess that might have gotten hot and started cooking. And then of course there's this bizarre hole in the side of the transformer. Kind of just looks like somebody's hit it with a drill or something by accident. Sick! But anyway, what we're going to do first is wire this up for European or UK voltage. It's currently wired up for US voltage, and so basically what it has, it's got 2 primary windings, 2 windings on the primary side, and they're connected in parallel for 120 volt operation. What we need to do is wire them up in series for 240 volt. On the left here, 120 volts, and you can see the coils are wired in parallel in series on the right hand side here. So I'm just going to do that first, see if it starts smoking or if we get some power out on the secondary. Right, this cable can come off, this can completely go for now, don't need it. And we need to connect 2 and 3 together. I'll plug that from there, and plug that too, and that as well. Go on to there. It is chunkier. I'm gonna have to use this danger cable for testing purposes. This one to 4. Okay, so I'm just gonna screw this back on here. Be very careful not to touch that. The mains flex is of course an American plug, so I'm just going to use an adapter. So, moment of truth, I've got this screwed back in, it's all wired up. Yeah, we have these dodgy cables here, don't touch that. I think we should be seeing about 30 volts on each side. There's 2 secondary coils. Switching on. Okay, it's humming. Nothing. AC voltage might help. 24 volts. Okay, 24 volts. I reckon that's all good then. So I've wired the transformer back into this first board, which amongst other things contains the power supply. So yes, plug it in again and see if anything starts smoking. Nothing getting hot. Just doing a sort of a touch test to see if anything's shorted. This resistor here is getting warm. Not too warm. It is a big chunky resistor, so it's probably meant to do that. Regulators down here, all look good. Not really doing much at the moment. Okay, pin 2 here, this is ground. Minus 31 volts, doesn't seem too good. Minus 15. Okay, and 14 should be something like 12 volts. 12 volts. Pin 6 of U11 should be, give me minus 12 volts. So let's see if it's doing it. Let's see if it's doing it. It's not, it's giving me minus 31 volts. It's a bit weird. Why is it doing that? Right, so where are we at with this? Okay, all the way down here. Q3, this is a power transistor, and that's meant to be giving me the minus 12 volts. Currently I'm getting like minus 30 volts. It's basically in circuit with this little op amp here, and these 2 resistors. Just looking at the service manual, and it's got a description here of the power supply. The negative 12 volt supply with the plus 12 volt supply forms a symmetrical voltage source. This is needed as a reference for the tune pot and the detune slider. It is also used as a reference for the headphone amp supply. A voltage divider formed by these two fixed resistors drops the negative 15 voltage to negative 12, which then sets the output of the op-amp U11, which I think is just used as a buffer. This is also a reference for Q3, a power transistor that supplies the headphone amp and also the line output driver. So yeah, that would imply that, you know, if I'm not getting minus 12 volts, then it's like something going on with one of these three components. Or it could possibly be Q3's doing something funny that's upsetting this. So I think what is happening here is it's Q3. Q3 is the power supply for the headphone amp here, this little LM386, and that's meant to give that minus 11 volts here, but in the service notes it says minus 22, so don't know which. Anyway, U11 here from 6, I should be seeing minus 12 volts, but I'm not, I'm seeing like minus 30 volts. So I think what is happening, if we follow from the collector of Q3 down here, it comes off of the sort of the raw DC side of the power supply, minus 29 volts. So yeah, I think that's where our 30 volts is coming from. And I think what's happened is Q3 is shorted out and it's just passing that voltage straight across to where we should be seeing minus 12 volts, but we're not. It's we've just got a path directly across this transistor here. Here is Q3 on the circuit board here, and I've just put the meter across it, and I'm literally measuring something like 300 ohms across the collector and the base. So I think if I desolder this, take this out, hopefully we should be getting our minus 12 volts. Oh, it's just dropped out. They don't always come out that easily. There it is. Removed. This transistor is the power supply for the headphone amp, but the headphone amp, I think, from just looking at the schematic, it also drives the line output. So yeah, if that's gone bad as well, then we wouldn't really be hearing any audio coming out, presumably. But anyway, all right, let's plug it back in and see if we get the correct voltages, or something's going to explode. All right, we're getting minus 7 volts now. It's interesting. It's made some sort of a difference. I think what I'm going to try next is desoldering these, getting them out of circuit, because these are involved in setting the output voltage from this op amp. So if I take these out of circuit and test them, maybe their values have drifted. We shall see. So just for fun, whilst the solder sucker is warming up, let's test out Q3 on a component tester and see what it says. And it says it's all right. But yeah, definitely made a difference taking it out. So we shall continue. Alright, this one's going to come out. There we go. So I'm just lifting one leg to take it out of circuit. 5.37. Alright, so both these resistors here, they're meant to be like a 1% tolerance, meaning they should be pretty close to the stated value on the schematic, and R62 as a whole 1k out, R63 as a whole 10k out, I think, so that's quite a big margin. So these two resistors here forming a voltage divider, so we've got 15 volts coming in one end, other end's connected to ground, in the middle that's our divided voltage. Even though the value of these resistors seems to be way out, we're still getting about minus 13 volts coming off of that, which is what it's meant to be. I think something's going on with this Q3, which I've taken out of here. Voltage I'm getting out from the output of the op amp is about minus 4 volts. Let's plug the meter in again and check it. And if I go to the middle of this voltage divider network of resistors, we can see getting sort of minus 13 volts there. It's meant to be minus 12, but kind of close enough. And if I go to the output of the op amp, pin number 6, yeah, minus 4 volts roughly. So that's wrong. Q3 is basically part of the circuit of the op amp, so that's why it's not giving the correct voltage. Previously in this video I did a pretty bad job of testing this transistor. When I look back at the footage I realised it wasn't very healthy. So yeah, I'm just going to show you again what's going on when I test it. So yeah, originally I just looked at it and thought, okay, yeah, there's a transistor. it is recognising it as a transistor. I didn't look too carefully and I sort of missed this diode that's appeared across the collector and emitter. That shouldn't be there, and also a lot of these readings here are kind of well off. Let's see what happens when I put the healthy transistor in. There you can see that's what it looks like, and we've actually got some values here. Yeah, we can also test these using a multimeter. Professional, very professional. With the meter set to diode setting, if I measure from the base to the collector, you can see it's seeing that as a diode, 0.5 volt drop across that. Now if I go to base and emitter, you get the same kind of reading. If I reverse the polarity, that should come up as open lead, which it is, and I shouldn't get any kind of reading across the collector and the emitter, which I don't. So that's a sign that that is healthy. I mean, it should be, it's new. Same test on the old one. Yeah, there we can see we're getting a drop of 1.3, so that's not so good. And if I reverse that, if I reverse the polarity, yeah, sorry, 0.129 voltage drop. 0.1, yeah, so that is clearly damaged. No good. So we've got Q3 reinstalled. Let's check the voltage. So we're looking for minus 12 volts and we're seeing minus 2.3 volts. The minus 13 volts going into the op amp and the output from the op amp minus 2.3. So what does that tell us? Bad op amp? Right, so next up I'm going to replace this op amp just here. Fairly common op amp, it's a 741. I've actually got some of these in my collection of stuff. Just noticed turning the key bed over that says made in Japan. Interesting. New one goes in. The op amp is installed. Let's see what kind of voltage we're getting. Minus 13.26. That is more like it, and that is probably down to the fact that, as we discovered earlier, let's zoom in, these two resistors here, their values have drifted quite a bit, so probably need to replace those as well. But that said, we do have close enough the right voltages, so maybe we might be able to get some sound out of this. Right, so I've powered it up again. I'm actually getting some kind of sound that sounds kind of synthesizer-y. The detune slider, one of the oscillators. You can hear it's trying to do something. Nothing from the filter. So yeah, basically what we've got going on here, wires which just have the insulation missing, I think causing all kinds of weird issues. I think a lot of these sliders and switches probably don't work that well either. And does anything happen if I try and play a note? It goes silent. Interesting. Until I... what happens if I hold my finger there? LFO's working. Random. So yeah, not completely dead. There is a well-known problem with these synths. There's a foam dust shield that sits over the sliders, which over time turns to gunge and drops inside all the sliders and switches, which kind of ruins them. It seems the easiest thing to do is just buy a replacement set, but as a remanufactured part is not that common, they are a bit pricey. So I'm gonna try and take some apart and clean them and see how well that goes. Alright, what I is gonna do here is, I've got multimeter and I'm just gonna test all of these sliders, these pots and these switches for resistance and continuity, and find out which ones are bad, because I'm pretty sure there's got to be some bad ones in here. I've just drawn a little picture of the faceplate so I can just mark off on there what's not working properly. Because basically if one of these sliders or switches is actually just creating an open circuit, then that part of the circuit isn't going to work, and that'll mean that audio is not going to pass through, or something's just not going to function. It's not going to oscillate or filter or whatever. So yeah, I'm not really going to go through filming all of this because that's going to be a bit boring. Set the meter to resistance or continuity. So I've been through all of these sliders, these pots and these switches. Most of the switches are okay. There's only one or two that are a little bit dodgy, but I reckon we can clean those up. Around half the sliders don't really work very well at all, and I'd say most of them are a bit dodgy. Most notably though, the two tone sources on the mixer, yeah, they're just not really working at all. So that would be why we're getting really sort of faint sound out of the output on this. So I think what I'll try first is desoldering these two and try taking them apart, see if we can clean them up and fix them. I'm kind of doubtful that that's going to work, but we'll give it a go anyway. Otherwise, I have found online that you can buy a complete new set of sliders for these to replace everything. That's the bit to try and clean up, and there's everything here. That's the little is this really worth fixing? Nah, this is shagged. That one cannot be fixed. Maybe this one. Yeah, this one's a little more intact. I think maybe try and give this a really good clean and see if it comes back to life. Well, it still feels horrible. Well, it's working a lot better than it was. So I've desoldered all the dodgy sliders. As you can see, I can just pull them off. I've just left them in place so I know what goes where. And all I'm going to do, like I showed you earlier, just going to unfold all the little tangs on the bottom here. And then the bottom pulls out. And you can give it a good clean inside. And then reassemble it. Stick it back in and solder it back in place. But yeah, look on my list here, everywhere I put a little X. I've desoldered one of them. I'll get to work on that. Soldering the thingies back in. Bit Pro Gold, deoxit, all the sliders. Feels horrible. Sweet. Right, so here I am repairing some of the cables on the looms. Yeah, it's a bit ugly, I know, but all that's happened really here is some of the insulation has kind of melted off. I think maybe it's a kind of a chemical thing. It's just right by these connectors, and all I'm doing is pulling the pins out. Get this one out. Come on. There we go. So de-pinning the plug, and then just getting a bit of shrink tubing to go over the bare wire. Once I've got the pin out, some of these have got some corrosion on them, so I'm just giving those a bit of a clean, a bit of a scrape. good as new. So yeah, probably the sensible thing to do really would just be to any of these damaged cables kind of take it out of the loom all the way and replace the whole piece of wire. But you know, I'm a bit lazy, and for the most part these cables are in good condition really. It's just a bit of the insulation has kind of melted off in places, and like I say, I think it's sort of like a chemical reaction, maybe the dust shield. I think maybe some of that's gotten to some of the insulation and caused it to sort of melt or something. But yeah, really it's just by these connectors. They're putting the heat shrinking on, putting it back together. Job's a good one. Yeah, the other option would be I'd need a replacement for these plugs and finding exactly what they are to work with the headers on the other PCB. Yeah, it just becomes a much bigger job. There we go. Yeah, in truth, this really does actually feel a bit bodgy. That's in. Nice. Right, that's that sorted. Okay, so we're getting somewhere with this. Bit more of a clear sound. The keyboard still doesn't work, but we're getting some filtering going on. So the filter kind of works. Kind of. I think all these sliders really need to be replaced. The envelope works. Yeah, what else? Sync. So it's just the LFO triggering the oscillator at the moment. It's all very shonky. I press the keyboard. Still doing this weird thing. Kind of bizarre. It's working a lot better anyway. Just got to figure out why the keyboard's not really spitting out the correct pitches. So update on more stuff that needs to be replaced. As mentioned earlier, U2 here is completely missing. Yeah, that's part of the polyphonic part of this keyboard, and it's a top-down octave divider IC. It's bespoke, it's kind of rare, and that's going to be a bit expensive to replace that. I've just been testing the circuit to do with the keyboard pitch control voltage. If we look at the schematic here, keyboard current source, we're going to see these voltages here, 2.5 volts roughly on pins 2 and 3. On pin 3 I am getting that roughly. Pin 2 I'm seeing more like 12 volts, and really that's just being fed with voltage from this potentiometer trimmer here and these resistors, and that's forming a sort of voltage divider network. So yeah, that's wrong, not getting the correct control voltage. The probe on 11 volts there, that's wrong, it's meant to be 2.5 or something. And if we go over to pin number 3, 2.694, yeah, that's more accurate. So yeah, the only other thing that's really in the circuit is these resistors, trimmers, and supply voltages, which are all good. On 4 there we're seeing our minus 15 volt supply, On pin number 7, 12 volts. Pin number 7, 12 volts. So that's all good. Supply voltage is all good. I doubt any of these resistors are bad. I'm just going to replace the op amp and hopefully that will resolve that. So the MG1 also has a polyphonic mode. It works on the same principle as an electronic organ. We have a chip, which is the main tone generator. It is controlled by a master oscillator and generates the majority of the frequencies in the highest octave. There is then some other chips, ICs, which divide these frequencies in half to make up the notes in the octaves below. This can be then divided in half again to produce the octave below that, and so on. The generated tones are basic square waves, and each output is connected to a summing amplifier through a switch. When a key on the keyboard is pressed, this will sound a note. The control voltage for the monosynth part of the MG1 is created through an entirely separate circuit, comprising of a resistor network switched via a second switch on each key of the keyboard. Basically, for each key there is a resistor connected in series. At one end of the string we have negative volts, the other plus volts. When a key is pressed, the voltage at that node is connected to the pitch bus, a bit like a sort of a stepped variable resistor or potential divider. The voltage across the circuit is controlled by an op amp. However, the polyphonic part is actually involved in the monophonic control part. The trigger detector circuit is connected to the polyphonic output, as in an audio signal. It generates an on-off CV gate when a frequency is present there. As we have the main IC missing from the polyphonic bit, there isn't going to be any control voltage generated by the trigger detector that's going to activate the VCA or envelopes. They won't know when a key is being pressed. So I've just replaced the op amp. That's the old one there. It's the new one there, U9, and I'm now getting the correct voltages. I go on pin number 2, should be seeing 3.58 volts. Close enough. And then if I go to pin number 3, should be seeing the same, 3.574, close enough. I can adjust those a little bit with these little preset trim pot thingies down here. But yeah, that's a lot better. So it might actually be working a lot better now. Let's find out. So we have a working keyboard. Sort of. The LFO is still triggering the notes, so yeah, that's down to replacing that chip there next, so we can get the trigger detector to work, and that just means that when a note's being pressed, it's sending like a gate voltage through to the LFO and the filter. But otherwise it's kind of working sort of okay. It is just still down to a lot of these sliders are a bit dodgy, so it'll be a case of replacing all those. It should be good. So I'm quite happy about that. It's not completely broken. There's not anything too horrendously wrong with this. That said, there's still lots more stuff to fix and repair on it. So as you can see, I've put everything back in the case, and I've plugged in some proper audio for this rather than just playing it through the headphones, just so you can get a better idea of how it's sounding. It's actually been a while since I've touched this thing actually, and it seems to be working not as good as when I last plugged it in. A lot of these, I think I need to replace all the sliders really. They're no good and are causing all sorts of weird issues. Anyway. Keyboard's not really tracking very well. Quite an octave, is it? filter's not really filtering very much. It's this emphasis thing. Interesting.